Today we shall talk about power electronics, and this should be the lecture number one. As the name suggests, power electronics means it's high power. Means we talk about high power electronics, which handles relatively high power. In the conventional electronics, normally we handle from a milliwatt to a few watts. But here it starts from a few watt to even gigawatt. So power electronics basically deals with high power, and in the high power system there are many special requirements which can be fulfilled with the help of power electronic devices and with the help of more precisely power electronic converters. And this power electronics is also named as industrial electronics some of the times because it was first evolved in order to cater the industrial requirements. But nowadays, it is spreaded into all sectors of our life. So let us start the presentation. So power electronics basically uh, takes the prerequisites from many subjects. You can see in the diagram. Before that, if you look at the transition, from milliwatts, it goes to the megawatts, even to gigawatts. So it's so huge. So it takes from the input from solid state physics. You require to have design knowledge on that, circuit theory, systems and control theory, signal processing, electronics, electromagnetics, power systems, electric machines, simulation and computing. These are the prerequisites in order to understand the power electronics and in order to use power electronics for satisfying different applications. Let us quickly look at some of the applications of power electronics in the aerospace. It is used mostly as space shuttle power supply, satellite power supplies, aircraft power system, and here in these aerospace uh, applications, you require to have high efficiency power supply where power loss is very small. Then in the commercial applications where business is the main motto, advertising, heating, air conditioning, central refrigeration, computer and office equipment, uninterrupted power supply, elevators, light dimmers and flashers. Industrial, this is the main area where from it was evolved, arc and industrial furnaces, blowers and fans, pumps and compressors, industrial lasers, transformer tap changers, rolling mills, textile mills, excavators, cement mills, welding. Number four, in the residential, it is used in the air conditioning system, cooking, lighting, space heating, refrigerators, electric door openers, dryers, fans, personal computers, other than entertainment equipment, vacuum cleaners, washing and sewing machine, light dimmers, food mixtures, electric blankets, food warmer, trays, etc. In the telecommunication, it is used as battery chargers, power supply, both DC and AC. Mostly, the AC is UPS. Transportation system, battery chargers, traction control of electric vehicles, electric locomotives, street cars, trolley buses, subways, automotive electronics, and in the utility system, It is used in high voltage DC transmission, excitation systems, gear compensation, static circuit breakers, fans and boiler feed pumps, supplementary energy systems like solar and wind power. Quickly, let us look at the advantages of power electronics over conventional electronics. High efficiency due to low loss in power semiconductor devices. The main reason is power semiconductor devices in high power electronics is used normally as a switch. And we know switch consumes very less power. I'm talking about practical switch. Okay, that's why it offers high efficiency. Then high reliability of power electronic converter systems. Why it is highly reliable? Because power electronic devices are always taken care by various protections from all corners, like over voltage protection, over current protection, short circuit protection, over temperature protection, DBDT protection, DIDT protection. So your device is completely protected. That's why device failure is less. That is why high reliability of power electronic converter systems are used, and it is expected to have very high reliability because normally power electronic converters are used in the online operations or online operations. Long life and less maintenance due to absence of moving parts. There is no moving part like electromechanical devices, and moreover, it replaces most of the electromechanical devices uh, by the solid state devices like power electronic systems. That's why it has long life and less maintenance and fast dynamic response because it is going to replace electromechanical converter system. Already it has replaced many. Okay, in other cases as well. Slowly, power electronic systems are taking the place of electromechanical converter system. Small size and less weight results the requirement of less floor space and therefore lower installation cost. And obviously, mass production of power semiconductor devices results, lower cost of the converter equipment. There are certain disadvantages as well. Power electronic converter circuits have a tendency to generate harmonics in the supply system as well as in the load circuit. That is why you need a separate measure in order to reduce the harmonic content. AC to DC and AC to AC converters operate at low input power factor under certain operating conditions, and in order to avoid low power factor, a special measure have to be adopted. Third, power electronic converters have low overload capacity. These converters must therefore be rated for taking momentary overloads, and as such cost of power electronic controller may increase because of these arrangements. Regeneration of power is difficult in power electronic converter system. Okay, then this is one of the major aspect which is also the cause of high reliability, high efficiency, and high stability of the power electronic systems because it's a closed loop. In the block diagram, we can see power electronic circuit is acting as a final control element, which actually follows the command of the control circuit via digital circuit. Then it gives the power to the load. And obviously, there is a mechanism of feedback, and this feedback goes to the controller. According to accordingly, it generates the command which has to followed by power electronic systems. There are another two block diagrams. The first one, you can see raw electrical power, which is initially unregulated, for instance. Then it's a regulated power. So in the control circuit takes the feedback, okay, and it goes to the raw electrical power systems. And if it is feed forward, the mechanism will be different. It takes the input and feedback, and then control signals are generated, and accordingly the converter operations can be controlled. In the second one, you can see converter 1 and converter 2 is used, which has two dedicated controllers. So, this uncontrolled AC, sorry, fixed voltage AC, okay, can be made uh, to have variable voltage, okay, according to the requirement of the AC motor. Second feature of this system is if one converter fails, another converter can completely take over the system. Power semiconductor devices, you have silicon control rectifier, power diodes, BJTs, power MOSFETs, IGBTs, and normally silicon control rectifiers are very much preferred in the high power system, very high power areas. But the medium beer nowadays is taken care by insulated gate bipolar transistor. Earlier, we had bipolar junction transistor and power MOSFET, but BJT has certain input characteristic problem and the power MOSFET has some output characteristic problem. That's why we developed a new device called insulated gate bipolar transistors where the good input characteristics of FADE and good output characteristics of BJT is taken together. And nowadays, almost in all low power and medium power application, IGBTs are used. In the very high power applications, still silicon controlled rectifier is used. Of course, slowly some of the devices are coming in, which is GTO and MCT. Mostly, if you look at the history of power electronic devices, it started in the year 1957. After that, power diode and thyristor was developed in the first phase. In the second phase, slowly GTO, GTR, power MOSFET, thyristor, all these things were getting prepared. It was the age of microprocessor. And late 1980s, we have got IGBT, power MOSFET, thyristor, DSP, because the transition is from the research level, it goes to the industry or in the application field, and it takes some time. So it's basically the development stage. And classification by control, if you look at this, there are three types of devices on the basis of control. One is uncontrolled device. Uncontrolled device is basically a diode. Uncontrolled devices sometimes required to use as in a converter design. Most of the cases, diodes are preferred to use as freewheeling diode. Power electronic systems has half control device, so it could be half controlled, it could be full controlled, either thyristor or IGBT nowadays we prefer. Of course, GTOs are also used on the basis of physical appearance or on the basis of number of legs of the devices. They can be identified as pin diode and Schottky diode comes under two terminal device. Three terminal devices are power MOSFET, JFET, IGBT, BJT, and thyristor. You can see quickly the symbolic representation. The first one is silicon control rectifier, the major member in the thyristor family. So sometimes it is known as thyristor also. Diap, that is also coming on the thyristor family, but it has very small applications like it can be used in light dimmers or it can be used for symmetrical firing of triacs, but it provides uh, two-way power control. Okay, then gate turn-off thyristor. This is better model than silicon control device, silicon control rectifier, in the sense that silicon control rectifier requires a separate circuit to make this device on or off. The turning on device is called triggering device, and turning off system is called commendation system. But in the case of GTO, simply with the positive pulse, you can make the device on, and with the negative pulse, you can make the device off. Rest of the working of gate turn off thyristor remains same as silicon control rectifier. Then we have diode. Diode is uncontrolled device. I've told you. IGBT. I've told you earlier. The input is looking like a MOSFET, and output is looking like a BJT. Of course, for very high frequency applications, we do prefer power MOSFET. The types of electronic converters, diode rectifiers, we are already familiar with. Normally, it is used in the low power, and for high power, we do not prefer because of having very less efficiency. The first one is AC to DC converter. Phase control rectifier mechanism is used in order to enhance the efficiency. Then DC to DC converter, from fixed DC to controllable DC, is available from DC chopper. It acts as a DC transformer. DC to AC converter, this is inverter. It's one of the essential model in the case of uninterrupted power supply in the solar power system. AC to AC converter, it has two categories. One is AC voltage controller, where voltage is getting controlled from fixed AC voltage. Voltage is getting controlled. If you want to control the frequency, then you require cycloconverters. So in both ways, by controlling voltage or controlling frequency, we can control the speed of AC motor. And the last one is static switch. It normally replaces uh, conventional electromechanical switch. In the diagram, we can see the common types of converters, rectifiers. As I've told you, from AC it converts a DC, and in the symbol, this is AC and this is DC. This is represented by a horizontal line. Inverter is opposite, so we have just swapped the position. Chopper, both are DC. In the case of cycloconverter, both are AC. Only the frequency of the output is getting changed. Either it could be step up or step in. Step up and step down. So in the case of AC voltage controller, again you have AC input and AC output, but only difference is that voltage is getting controlled. Scope of power electronic system: zero point 0.1 to 10 watt battery operated equipment, flashes, strobes, 10 to 100 watt capacity, satellite power systems, typical offline flyback SIP supply, 100 to 1 kilowatt computer power supply blender, 1 to 10 kilowatt hot tub, 10 to 100 kilowatt electric car, eddy current braking, 100 kilowatt to 1 megawatt bus and micro SMEs, 1 megawatt to 10 megawatt SMEs, 10 megawatt to 100 megawatt magnetic aircraft launch, big locomotives, 100 megawatt to 1 gigawatt power plant, 1 gigawatt sandy pond substation. In terms of power and frequency rating, if you look at the power devices, higher for higher power we use silicon control rectifier. For low power and medium power we use IGBT, which replaced BJT and FET. But still we use FET for higher frequency. Okay, for very high frequency applications, we do prefer MOSFETs. Now, contributing area, if you look at in the electronics, it deals with solid state devices and signal processing circuits. And in the power system, it deals with static and rotating power equipment. In the control system, it deals with steady state and dynamic characteristics of closed loop system. Now, for considering power electronics, some special attributes you have to remember, and you have to have a best practice like this. We need to study the switching characteristics of the devices, because mostly all the devices are used as a switch in the case of power electronic applications. So, along with input output characteristics of the device, we need to know the switching characteristics, which will basically represent the speed of response. Now, the functions or operations of power electronic converters are also dependent on types of loads. Okay, if it varies from resistive to inductive to capacitive, we have seen the performance of the power electronic devices has to be is changing or affecting. So that is why we need to have a special correction mechanism so that it should not change because of the change of the load. Semiconductor device protection, I told you, it has utmost importance. So, in order to protect the device from all sorts of uh, voltages and currents or temperature, we use protection so that failure rate can be reduced. Power saving and efficiency is specially taken care, because here it is the main motto of power electronic applications. In circuit test, normally we do not take out the components from the circuit, then we test it. Rather, when the system is working, we test it in circuit. And since power electronic converters are producing huge amount of harmonics, we require to have a technique of harmonic reduction. This is where I'll just stop today. Next day, I'll carry on with lecture number 2.